Imagine you're falling through the sky. The wind roars past your ears, the ground rushes up toward you, and your heart pounds. But then, snap! A canopy bursts open above you, filling with air. Instantly, your fall slows, and instead of plummeting, you begin to glide. It feels like magic, but it's really science. This is how a parachute works. Now let's test something. Picture two objects dropped from the same height. One is just a ball, and the other has a parachute attached. Which one hits the ground first? You probably know the answer, but why does it happen? The key lies in something called air resistance. As you fall, gravity pulls you toward the ground, making you accelerate. But at the same time, air pushes against you, trying to slow you down. The more air something catches, the slower it falls. That's why a feather drifts gently while a rock drops straight down, and why a parachute makes all the difference. Without one, a human in free fall can reach speeds of around 120 miles per hour, fast enough that hitting the ground would be deadly. But the moment a parachute opens, everything changes. The large fabric canopy catches the air, drastically increasing air resistance. This force pushes upward, counteracting the downward pull of gravity. The bigger the parachute, the greater the resistance, and the slower the fall. That's why parachutes are designed to be so large. They need to create as much drag as possible. At first, there's a sudden jolt as the parachute inflates. Then, the descent becomes smooth and controlled. Instead of falling at 120 miles per hour, a person under a parachute slows down to around 12 to 15 miles per hour, a much safer landing speed. Parachutes come in different shapes and designs. Some are round, designed mainly for slowing a fall without much control. Others, like the rectangular ram air parachutes used in skydiving, allow jumpers to steer and land precisely where they want. By pulling on steering toggles, skydivers can shift their direction, almost like piloting a glider. This principle doesn't just apply to skydivers. Space capsules re-entering Earth's atmosphere use massive parachutes to slow their descent before landing in the ocean. Even the Mars rovers used parachutes to slow down as they entered the thin Martian atmosphere. But what if a parachute was too small? Would it still slow the fall enough? Think about that for a second. Too little air resistance, and the fall remains dangerously fast. That's why scientists carefully design parachutes to be the right size for the job, whether they're carrying a skydiver or a space probe. You can see this principle in action with something as simple as a piece of paper. If you drop a crumpled ball of paper and a flat sheet at the same time, the flat one falls slower because it catches more air. That's the same reason parachutes work. So the next time you watch a skydiver floating through the sky or see a spacecraft drifting down on a giant parachute, you'll know exactly what's happening. It's not magic, it's science. Saving lives one fall at a time.
Got a question about how something really works? Drop it in the comments and we might cover your topic in our next video.